Hello, and welcome to Lecture 1 of Electric Charges and Forces in Phys 1201. And in this lecture, we're going to establish a model that we'll use to describe charge and to think about what charges do. To start off, we want an operational definition of charge. And what I mean by an operational definition is that it's a definition that's in terms of practical operations or procedures that we can carry out and observe the result. So our starting definition of charge is that charged objects will exert a long-range force, we call it an electrical force, on uncharged or neutral objects. And because it's easier to observe these electrical forces on the neutral objects if they're light, we test this using very light things like paper or dust or something like that. The piece of plastic and the piece of wool will not pick up these pieces of paper, but if I rub the plastic with the wool, then after rubbing, the plastic will pick up the pieces of paper, and the wool will pick up the pieces of paper. The same is true of this glass rod, which I can rub with a piece of vinyl. At first, they don't pick up the pieces of paper. We say that they're uncharged, or we'll call it neutral when something is uncharged. But again, after rubbing the vinyl on the glass, both the glass and the vinyl will move around and pick up small pieces of paper. There's nothing special about using paper. The main reason to choose paper is that it's light and easy to move, so we could have a more sensitive test if we use dust. For example, you can see here that the plastic rod will also exert a force on a stream of water, and so will the piece of wool. The point here is that we have a simple experimental test that allows us to distinguish between things that are charged and things that are neutral. And we can see other things like, for example, this magnet. The magnet is different. There are lots of things it'll pick up. All these various pieces of steel it will pick up quite easily. However, it won't pick up the little pieces of paper. This tells us that it isn't charged. It's not exerting electrical forces. So we will eventually talk about magnetic forces, but the point I want to make right now is that magnetic forces are very different from electrical forces. The magnet is not charged. Another property of charged objects is that once they are charged, we can do what's called discharging them. So I'm going to charge this rod and demonstrate that it picks up the paper. However, after that, if I touch it enough and roll it around on the desk a bit and generally put it in contact with a lot of other things, it loses its charge. It no longer exerts electrical force on the paper, and so it has returned to being neutral. One thing to notice, though, is that it was a little difficult for me to get it to return to being neutral. In a little while, we'll see other things which aren't difficult to discharge. Now here I have a neutral piece of plastic, and I'm going to put it on a hanger. And here's another neutral piece of plastic, and note that it doesn't exert any force on the other neutral rod. Also, a neutral glass rod exerts no force on the neutral plastic rod. The point here is that there's nothing fundamental or special about plastic or glass that's making them exert forces. It's that when we rub them with selected other materials, we change their state, and they become this thing we call charged. Up until now, we've only looked at how charged objects affect neutral ones, but now let's start looking at charged objects and how they affect other charged objects. So I've charged a plastic rod this time, and I'm putting it on the hanger, and now I'm charging another plastic rod, and what we observe once it's charged is that the charged end repels the end that I rubbed on the other one. However, notice that if I use the end that I didn't rub and put it near the end that I didn't rub on the other rod, it has no apparent effect. It's only the ends that have been rubbed that repel each other. Similarly, I can charge a glass rod and hang it, and charge another glass rod, and once again, The ends that have been charged repel each other, but the ends that haven't been charged have no apparent effect on each other. On the other hand, when I hang a charged plastic rod and put a charged glass rod near it, the charged glass rod attracts the charged plastic rod. But once again, the uncharged ends exert no forces on each other. Only the charged ends attract. Also, when I use wool to charge the plastic rod, the wool attracts the plastic rod. So the wool seems to have the same kind of charge on it, perhaps, as the glass has. Similarly, when I charge the glass with a piece of vinyl, the vinyl attracts the glass. The idea of what we mean by a thing being charged, and the fact that this is based on observations and experimental evidence, is often hard for people to wrap their heads around. So I'm going to ask you two questions, set up two situations for you to think about. So here's the first. We have some rod, it's made of something, it doesn't matter what, and we observe that it moves around iron filings, and that the iron filings will stick to it, but it seems to have no effect on dust or bits of paper. So based on this evidence, is this rod charged? Here's the second situation to think about. Now we have some rod, again of some material, it doesn't matter what, and it doesn't move around pieces of paper or iron filings or anything else without touching them. But if it's touched to these objects, they will stick to it. So based on this evidence, is this rod charged?